pseudo calculus problems. Pseudo calculus problems. Okay, so we promised for the new problems. So that is the concept that we had started. What is the idea is to make people understand that what is differential calculus and what is integral calculus. So that is the concept that we are pursuing. Okay, we have said that if I have if I have to calculate a kind of a division, then division is transformed into differential calculus. If I have to calculate multiplication, then multiplication will be transformed into integral calculus. Okay, these are the two things. What about the third thing? That's it. The calculus means if I am doing division of two algebra and numerator is dependent upon denominator, being denominator as an independent component, then this division will be has to be must. This division has to be transformed into differential calculus must. If we are multiplying two items and one is dependent upon another and another is independent variable, then this has to be converted into integral calculus. Multiplication will not work. Okay, thank you very much. What you are saying now? What I am trying to say is x square into x is not x to the power 3. Okay, many people would say, how come you can say x square into x is not x to the power 3? X square by x is not x. Here is the problem. X square into x is not x to the power 3. X square by x is not x. Okay, we have demonstrated it very well. Why x square by x is not x rather than 2x. Why? Why? Okay, why x into x is not x square? It is x square by 2. Okay, these are the concept of integral calculus and differential calculus. Why they came into picture? Why they came into the picture is that one thing is called y division transformed into differential calculus. Division means if I say y by x per unit x is it brings how many unit of y. Please watch the terminology. Y by x per unit of x brings how many unit of y. Dy by dx per unit per unit change in x brings how many unit of change in y. There is difference. Why there is difference is numerator, that is x square, is dependent upon denominator x. Means per unit, if I say per unit in denominator brings how many in numerator, that is that that is all right. Means that is, but if I talk about the change, per unit change in denominator brings, there are two terminology. One terminology is per unit of denominator brings how many unit of numerator. That is one idea. Another idea is per unit change in denominator brings how many unit of change in numerator. These are two things. Okay, what is two things? What is two things we are talking? Okay, we will make it clear. What we are trying to make it clear here is that I have always given the example. Now consider I have two bags. One bag is filled with orange and other bag is filled with tamarind. Okay, in orange bag there are three oranges. This is how it is filled. The in one bag there are three oranges, whereas in another bag I have 12 tamarind. How many tamarind per orange? That is tamarind by orange. Makes sense? So that is 12 by 3, that is 4. 4 tamarind per orange. Okay, now If I'm going to add one orange to the orange bag, means there is a change of one orange. Makes sense? Both are two different things. If tamarind bag has 12 tamarind and orange bag has 3 oranges, then how many tamarind per orange? Then 3 tamarind per orange. Now in the orange bag, I'm going to add one orange. In that fashion, how many I need to add in the tamarind bag? If I make 1 unit of change in orange, then how many unit of change I have to make in tamarind bag? These are two different things. They may be same, they may not be same. Make sense? Okay. How it can be same? It can be same in a way that if I carefully watch the orange bag and tamarind bag at any instant, when there were 3 oranges in the orange bag, then there were 12 tamarind in the tamarind bag. After some time, I saw if there is 15 orange in orange, I'm sorry, 5 orange in orange bag, then there are 20 tamarind in tamarind bag. After some time, I saw when there is two orange in orange bag, then there is 4 orange in tamarind bag. So looks like per orange, per orange is 4 tamarind. 2, 8. If there is 2, there is 8. If there is 3, there is 12. If there is 5, then there is 20. Which looks like per orange, there is 4 tamarind. Looks like. Now, at any moment, consider there is X orange. This proves that there will be 4X tamarind in the tamarind bag. At that moment, if I add 1 in the orange bag, how many I need to add in the tamarind bag? That answer is 4. After that, orange bag will have X plus 1, whereas tamarind bag will have 4X plus 4. Okay, it will result into again 4. So that tam per orange, how many tamarinds are there? 4. If I make 1 unit of change in orange bag, means if I add one orange or subtract one orange, 1 unit of change if I make in orange bag, at that moment the orange count is X. The orange count in orange bag is X. If I make 1 unit of change in orange bag, how many unit of change I need to make in the tamarind bag? That is different than the whole division. So when orange bag has X orange, at that moment if I make 1 unit change, I make it X minus 1 or I make it X plus 1. In that fashion, how many tamarind I have to tamarind I have tamarind change in tamarind I will see. Either some tamarind it will reduced or some tamarind will get added. For 1 unit of addition or 1 unit of subtraction in the orange bag, when orange bag has X number of oranges. This typically falls in rate of change in differential calculus. When it make right now, when that y by x tamarind by orange equal to 4, that is numeric, then no calculus is required. When it is numeric, no calculus is required. Any moment if I have x, then at any moment I saw many instances of orange bag and tamarind bag. In many instances, I saw always when it is x, it is 4x. Okay, in that way, the y by x is 4. It is constant. In that fashion, if I make 1 unit of change in orange bag, either I add or subtract, 4 unit of change I will see in the tamarind bag. Either it will get added or subtracted. Here, we don't need calculus. Where we need calculus, I have given this example. Like consider that orange bag has 2 oranges and tamarind bag has 4 tamarind. Orange bag has 4 oranges at any moment. Tamarind 2, 4. The orange bag has 4 oranges at any moment. In that fashion, the tamarind bag has 16. Here we have 5, then it has 25. Here it has 7, it has 49. This proves that any moment if I have x in the orange bag, at that time I have x square in the tamarind bag. How many tamarind per orange? That is x square by x, that is x. Means the one is how many tamarind per orange. The answer is X. What is X? X is the amount of orange at a particular moment. Okay, what is the change in tamarind I see when there is 1 unit of change in the orange bag? Then it is x square by x equal to x. This is what anyone would think. The way we did in earlier example, x means any moment if I earlier it was 4 constant. Now it is x. Any moment if I have x amount of orange in orange bag, if I make 1 unit change, I make it x plus 1 or x minus 1. At that time there will be x change. It will be seen in the tamarind bag. So when here it is x, here it is x square. When I add 1, it becomes x plus 1. Here it will become x square plus x, because that I need to change. X square plus x divided by x plus 1. It should be x square. It is not. So means if I have 10 oranges, then I have 100 tamarind. If I add 1 here, then it becomes 11. Then I have to add 10 here, x. It becomes 110. It should be 121. Or if I take out 1, 10 to 9, okay, then x. Then I have to take out 10 here. It will become 90. It should be 81. Nowhere it is similar. Means that the number in numerator per unit denominator is division. Per unit change in denominator brings how many change in numerator. Many cases it will not be division, because we saw the answer and it is not correct. X square by x, x square plus x by x plus 1 is not x, is not x square. It should be x square. Or x square minus x by x minus 1 is not again x square. X square minus x means x, if I take out, it becomes x minus 1. X square minus x, x if I take out, it becomes x minus 1. Divide by x minus 1, it becomes x, not x square. X square plus x divided by x plus 1, if I take out x, it becomes x into bracket x plus 1 by x plus 1. It again becomes x. It should be x square. What is the problem? Problem is it is not differentiation. Here we need differentiation. What you want? I want per unit change in denominator brings how many unit change in numerator? That is x square by x. Okay, x square by x. Now it will be rewritten as dx square by dx, because it will be differentiation now rather than integration. Why? Numerator is x square, that is function over x. The the tamarind in bag in the tamarind bag, the number of tamarind any moment is dependent upon number of orange in orange bag. It was dependent there also. It was 4 times. Then make a differentiation. Who is stopping you? Any division can be transformed into differentiation without losing any information. Okay. Now we have x square by x, means numerator is function over denominator. Bottom is orange, numerator is tamarind. So any moment the tamarind count is dependent upon the orange count. If that is the case, then division will become differentiation. Okay, it becomes dx square by dx. It will become 2x. Now let's try. If I have x here, I have x square here. I have x here and I have x square here. Now here I am adding 1 to the x. Now new count becomes x plus 1. There the count is x square. X square plus 2x, because I am going to add 2x now. So it becomes x square plus 2x divided by x plus 1. Okay, if someone does, then x square will come out x plus 2 divided by x plus 1. This has to be solved. But sir, okay, someone can try, I don't know. X square x into x plus 1, x plus 2. X plus 2 can be written as x plus 1 plus 1. It will become x square into x plus 1 plus x square divided by x plus 1. First will become x square. First will become x square plus another will become x square by x plus 1, whatever it is. X square will be retained in this fashion. Means it is better. Okay, in normal fundamental, someone can try it. In normal fundamental, someone can try it. Like if I have 10 orange here, I have 100 tamarind here. If I make it 9, then I have to reduce 20 here. 2 into x. It will become 80. It will become 9. 9, it should be 81. One error is there because we have taken a small measure and it is discrete, not continuous. If I add 1 here, 10 to 11, then it will become 11. Here, 10 to 11 with 20 I have to add. 120. Okay, now it should be 121. All right. If there is 18 here, then how much is 18 into 18? I don't know how much. Consider simple case. Consider it is 15 here. Here, then consider it is 20, 20 consider it is 20 here. 20 and here it is 400. If I add 1 here, it becomes 21. 20, then it should be 21 into 21. 21 into 1 is 1. I have 2 in hand. 21 into 2 is 42. 441. 441 it should become. I believe it is all right. 441 it should become. Now I have 20 and 400. If I add one more, it becomes 21. Now this will 20 into 2. It will become 440. Only error is 1 only. So if I go higher side, then no problem. This is differentiation. This is also called anti-integration. What is integration in this similar manner? Integration means if I am multiplying two items and one item is dependent upon another. Difference division to differentiation. Numerator is dependent upon denominator and denominator is independent component. Like orange is independent component. Similarly, if I am multiplying two items y into x and y is function over x, fx into x, then it cannot be simple multiplication. Example can be, consider I am multiplying x into x, x into x. Then what is the multiplication? X square. Any would answer quickly, x square, but that is not always true. Why it is not always true? That first x is function over another x that is dependent upon x. They're tied to each other. They're not independent. One x I have taken, another x I have taken, and I'm multiplying, and it becomes x square. That is not true. The left x I'm taking x into x. Left x is dependent upon right x. Now they are tied to each other. How they are tied to each other? Consider this is origin. I'm drawing a graph now. Consider this is origin. If this is origin, okay, so consider this is origin. This is origin. If this is origin, then this is the graph of x. When this is x-axis, this this is origin and this is x-axis. If this is x-axis, I'm drawing graph of y into x, where y is x, y is the height. Okay, I am in y-x plane. So in that sense, if this is origin, I'm drawing a graph like this. If I'm drawing a graph like this, when x is 0, that is x-axis, the y is also 0. Y equal to x. Y into x we are trying. So let's see what is y. Okay, y equal to function over x. Y equal to x. We are trying y into x. Now this is x-axis and here we have origin. If this is the origin, then in that fashion we have when this x-axis is 0, then height is also 0 because it is x. When x-axis is 2, then height is 2. When x-axis is 3, height is 3. It will be like this. Okay, I'm trying to calculate x into x. When I do multiplication of two items, multiplication can be achieved by multiplying two sides of rectangle. What is 5 into 2? 5 into 2 is one rectangle side is 2, another rectangle side is 5. 5 is height and 2 is width. That is the area of the rectangle is the multiplication. This is consistent thing. If I want to multiply any two items, let's draw a rectangle and multiply width with the height. You get the multiplication because you are trying to, by calculating area of a rectangle whose sides are the operand of the multiplication. Multiplication is an operator. Is an operator, and operand are 5 and 2. If I take these operand as side of rectangle and calculate the area of rectangle can be measured without multiplication also. There are ways to calculate the area of rectangle. If I am able to calculate area of rectangle, then we are able to calculate the multiplication. Similar way, if I am trying to calculate y into x, I'll take a rectangle whose one side is x and another side is y. Calculating the area will give the multiplication. Make sense? One way to calculate the multiplication is repeated addition. What is 5 into 2? That is 5 plus 5. 5 added 2 times is 5 into 2. That is also a way to calculate multiplication. Or what is y into x? Y plus y plus y plus y plus y x time. That is also a way to calculate the multiplication. Another way to calculate multiplication is take a 2D shape whose one side is x and another side is y, probably a rectangle, and calculate the area underneath it. That will be y into x. Calculus stick on the area fundamental. Okay, in area fundamental, one side is x, another side is y. Whatever the area it is making, calculate the area. In that fashion, if y equal to x, y is function over x. If y equal to x, it will make a shape like this, triangle. Now, when x equal to x, at any x equal to 1, 2, 3, 4, 5, 6, x, any x, then height will be x again. What is area of this shape? That will be multiplication of y into x, where y is dependent upon x axis. They are tied to each other. They are not independent. In that fashion, the area of rectangle will be 1 by 2 x square. Area of rectangle will be 1 into 1 by 2 x square. X square will be area of rectangle. Area of triangle will be half of it. So y into x, fx into x into x will be x square by 2, not x square. That is the problem. X square by 2. Okay, how we calculated? We calculated through the graphical way, and that is integral calculus, where one is dependent upon another. That is x square by 2. Now, any can mug up that multiplication of x into x is x square by 2. If it is x square by 2, the reverse of multiplication is division. In that fashion, the division of x square by 2 with x should result in x, not x by 2. So there we say dy by dx, that is differentiation, and here we say y into dx rather than y into x to differentiate between normal multiplication and integral multiplication, calculus multiplication, that is also called integral calculus. Anyway, thank you very much. Can you give some more examples? Okay, I understood your sentiments that this is, but you said that integration is repeated addition also. Can you prove that? Integration is substitute for multiplication. We understood through graphical way. It is it is substitution of multiplication. Is it really substitution of repeated addition? I believe it is. All right. Okay. What is the area of this circle? That is under question mark. Consider the radius of the circle is r, that is fixed. Radius of the circle is r, that is fixed. What is fixed? What is radius and what is fixed? Can you demonstrate? Okay, what is this circle? What is this circle? This circle is centered at the origin. The circle is centered at the origin, and this is in xy plane. This is x-axis and this is y-axis. This is in xy plane. Consider this point is center. If this point is center, then it is centered at the origin. If it is centered at the origin, then from the origin, this is the radius. Radius is up till here only. This is not the full line is radius. Okay. So this is the radius. Radius starts from origin and it hits the circumference. Now, radius is moving like this. Okay, it is moving so that it forms a angle. If radius, if radius is at, looks like you're saying that it is xy plane means it is Cartesian coordinate system. Yeah, this is Cartesian coordinate system. And you are saying like this looks like x-axis. Yes, this is x-axis. And this is y-axis. Now there is a radius. It is moving from here. Consider this is the initial position of the radius. And radius started moving from here. And it moved like this. It came, it is now, it is just still here. Stand still here. Radius is up till here only. This is not the radius. Okay, up till here only. Now it makes theta angle from this base. Okay, means what we are trying to say that radius is moving in a circle where theta is increasing. Radius is constant r. It can be 1 by 2, it can be 1, anything in real number domain. In real number domain, not integer number domain. So radius is r and it is moving like this, like a minute needle in the clock. It is moving like a second needle or hour needle, whatever it is. Now it starts with 0 angle and then 90 degree. It starts with 0 angle. The radius starts with 0 angle and then 30 degree, 60 degree, 90 degree, 180 degree, 270 degree and 0 degree, 360 degree or 0 degree back. Okay, now please watch it carefully. This may change someone's life, I am 100% sure. Now, consider, now I'm trying to calculate area of this circuit. I have talked about innumerous way calculating the area of the circuit, innumerous way. Now let's calculate area of the circle. Area of the circle, if we are trying to calculate, let's see. Now this is radius of the circle at any moment. Now it moved delta theta from here, makes sense? Or theta angle from here. It is not at x-axis, it is somewhere. Radius is somewhere in the vicinity. And then from here, it moved theta, consider theta angle it moved. It moved theta angle. If it moves theta angle, then how much is the area it forms here? Hop, too much confusion. What is the area it is making here? This area, if I talk about this area, this is the line, this is the arc line it is making. Okay, at this arc line, at this point, if I take a tangent, it will be perpendicular here. Okay, does it form a triangle? I'm not talking about this hole. At this point, we had two lines. We have two lines, radius at two positions, and they make theta degree with each other. One line is this line, first radius. Second line is this line, second radius. Okay, radius at second position. Consider this is R1 and this is R2. Now at R1 when it is hitting the arc, at that point I am drawing a tangent. Now there is a third line, that is this line, that is coming from R1 and touching the R2 in 90 degree phase. 90 degree means this angle is 90 degree. Sorry, this angle, too much confusion. This is the radius and this is the point it is touching. If I take tangent here, then this angle is 90 degree and then it is going and hit at this point. Now there are three sides. One side is this side of triangle and other side is this side of the triangle and other side is this side of the triangle. It makes a triangle. It makes a triangle where this is 90 degree. Okay, what is the area of this triangle? No one knows because we really don't know what is this length. Little bit less than this is the radius and this is full radius and this is the line. Okay, consider this angle is very small. I don't like this explanation, but this is how it is. For some time, just consider it is very small, infinitesimal small. I say it d theta. Okay, if it is d theta, angle is so small, then the way I drew a perpendicular from here to here, that perpendicular line is more or less arc only. Okay, if this is the what we are saying, and we draw a perpendicular line here like this, the angle is so small that this perpendicular line it tends to be the arc length only. In that fashion, the what is the area of this triangle? Then this line, this is 90-degree and it is hitting here. This is radius, and this is perpendicular. In that form, it forms a triangle. And area of this triangle is height by width into half, the way we said earlier. So the area of this triangle is this height, that is the arc length, into this radius by 2, because if it makes full rectangle, then that will be this arc length, this arc length, this radius and arc length. But since it is half of it, that is triangle. Any rectangle, half of it will be a triangle. Okay, with hypotenuse. Now the hypotenuse and this both are arc, and this is the arc. What is the length of this arc if this angle is d theta? This is r d theta. The area of this rectangle, this triangle, is 1 by 2 into r theta, r d theta. R square by 2 d theta is the area of this rectangle, is this triangle. Now let's keep moving it. What are you saying? Start now. So consider this radius is at x-axis, and I moved delta theta 1. Delta theta 1. Then what is area of this triangle? This triangle area is 1 by 2 r square delta d theta 1 or delta theta 1. Now from here, now this we made a triangle like this. We made a triangle like this. Let's move this to another angle called d theta 2, where d theta delta theta 2 is again small. What is the area of this circle? This portion is. This portion area is 1 by 2 r square d theta 2. Now from here, let's make another triangle here. Make sense? Keep doing like this. Now the area of this circle is addition of all triangles we are making. That is 1 by 2 r square d theta 1. Makes sense? Plus 1 by 2 r square d theta 2 plus 1 by 3 r square d theta 3. Keep doing that. At the end, it will be 1 by 2 r square d theta n, where theta 1 plus theta 2 plus theta 3 plus theta n equal to 360 degree, 2 pi. Okay, if I add all the triangle, it becomes the area of the circle. Can I this is typical case of repeated addition. 1 by 2 r square in bracket delta theta 1 plus delta theta 2 plus delta theta 3 up to delta theta n, where n tends to infinity. Makes sense? Maybe delta theta 1, delta theta 2 are not at same, but they are very small, and n tends to infinity. This is typical case of repeated addition. Can I transform this repeated addition into calculus? I said that integral calculus is representation of multiplication, and these explanations are not available in any of the book. Anyone can try. The integral calculus is nothing but repeated addition, representation of repeated addition or multiplication. Multiplication we saw, x into x become x square by 2, or here also we are seeing. Repeated addition can become integral calculus. We will see more on it. Please do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +91 is the India country code. 9483160610 is the telephone number.